pens up, pencils down, calculators are out. So the last lesson we did was 1.6, 1.7. We talked about functions. We talked about tables of values. We talked about domain and range, and we talked about graphing. So today I'm not going to call on volunteers. I'm going to reveal the different answers. And a couple of the parts have different possibilities, so pay attention. Before you mark your own answer, wait. Don't mark your answer wrong or right away. You got to hold on. So, number 1, pick 4 inputs and make an input-output table. I let you choose the inputs, which means everybody's table might be different. So, here's my table. I chose 70, 80, 150, and 300, and my outputs were 0, 40, 320, and 920. Give me a thumbs up if you used the exact same inputs that I did. Good. Nobody should have a thumb up because nobody did pick those. But that doesn't mean you're wrong. It means that you picked different inputs. So let's go around and see what you picked. We'll start with Alexandra, Fung, then we'll go to Sebastian, and then Edgar. What do you use?
100, 200, 500.
Why did you do it wrong? You were doing fine so far. 100, 200. You went over 300. Yes, that is a mistake, but you started out okay. Who did I say was next? Fung.
70, 71, 72, 73.
Okay, so she is fine because she went from within this range of this span of numbers, 70 to 300. 70, 71, 72, 73. Now, I will say that it's not the best set of inputs because if this is the sequence of numbers she had to choose from, she only represented this bottom little piece right here. It would have been better to spread out your inputs to span the whole thing, and that's why mine goes 70, 80, 150, 300. And so Alexandra did start out very well, but then she made a mistake and went over 300, which she was not allowed to do. But Fung is not wrong. I'm just saying it wasn't necessarily the best choice. Sebastian and then Edgar, what'd you use?
70, 80, 90, and 100.
Very good. What'd you use?
90, 100, 100, 200.
Outstanding. Anyone else have one that they'd like to share? Go ahead, Davis.
300, 100, 220, and I did 100.
Okay, what was the first one you said?
300.
Okay. Now, when you're picking your inputs and you're writing them down, you want to go in order. So, I don't know if you actually wrote 300 and then 100 next, but you would want to put them in sequential order. Lowest number and then lowest number going up to the highest number. What did you use, Matthew?
I used 100, 150, 200.
Outstanding. Very good job. So, the only people who may have gotten question number 1 wrong is anyone who did not use numbers from 70 to 300. That is the given domain. Those are the limitations. We'll talk about that in a few minutes. Are there any questions so far? Good. Now, number 2. Is this a function? And simply, yes, it is. Number 3 depends on what you did for number 1. So, whatever you chose for your inputs, that's your domain, and whatever you got as your outputs, that's your range. It has to be in the same order. So here's 70 and the 0 go together, 80 and the 40 go together, 150, 320 go together, 300 and 920 go together. So they have to be in that order. So go ahead and mark your own paper. Now, I'm going to reveal the graph. Unfortunately, I used a computer program to do the graph, and it doesn't allow me to do a graph with only points. It automatically draws a line through it. So my graph is going to be a line. Yours should not have been a line, so I apologize if that's a little confusing. So here's the graph, and let me move the page up a little bit. Yours is not going to look like this. Yours is going to be a sequence of points, but your sequence of points should follow the same trend that this line is following. So see if your graph matches to some degree mine. So, comments and questions on the graph. Now, let's explore the scenario for a moment, and let's explore the domain. The domain is given as any number between 70 and 300. Could someone who's really working at a high level today and who's being thoughtful explain why 70 is the minimum number that we are allowed to use? Why? Got a bunch of people who think they know. We'll start with Danielle and then John.
Because all the other numbers would be
What numbers?
anything under 70.
Okay, what were you going to say, John?
Mine was something like that. I was going to say that 70 times 4 minus 280 would be 0, so that can show if you were to make any numbers lower times 4 minus 280 would be a negative number, which then would show that they would be losing.
Okay. And so you take what Danielle said and what he just said, and that's the critical piece. That was a brilliant interpretation he just made. If you go below 70, they will lose money. And if you're in the business of trying to make money, you definitely can't lose money. So this is a school. I mean, you think about the context. This is a school, and they're trying to make at least a little bit of money. 70 is the minimum amount because that just gets them their money back. Like he said, that gets you $0. They've just earned their money back. Now, could someone explain why 300 is the maximum number? Why can't we go over 300? Because, I mean, if we could sell 400 tickets, that would be better, right? Nicholas? Nathaniel?
Because that's the maximum amount of seats in play.
Yeah.
Theater.
Yeah, the theater can't hold more than 300 people. They don't have 301 seats. They only have 300. So if you sell a 301st ticket to somebody, they have nowhere to sit. That's unfair to that person, so you don't. In a school, there's other issues, like there's legal issues with fire hazards and things like that. We are only allowed a certain number of people in an auditorium. So that is why 70 is the minimum and 300 is the maximum. Does anyone have any questions about that? Okay? Any questions about anything else? Okay, put this warm up to the side. Today's lesson is a critical lesson. We're going to be studying distributive property and the idea of combining like terms. Everything we've done so far this year has been to prepare you for everything we're going to be doing on that back wall. So turn and look back there. In chapter 3, which we start tomorrow, we're going to start solving equations, graphing, manipulating equations. We're going to be doing the very advanced stuff that you've been preparing for. But to do any of that, you have to have the proper foundation skills to be successful. Distributive property and the idea of combining like terms are two seriously critical skills to be able to handle any of the other material we're going to be studying. Today's going to be a lot. There's going to be a lot thrown at you. You're going to have to do your best to digest what you can, and it's going to take some practice and some time to sink in. If you have questions, raise your hand and ask questions. Don't let things just go by. Okay? So first, the first major idea, distributive property. You were introduced to it last year. We are going to be building on what you learned last year quite a bit. Here's how the distributive property works. First of all, you have to be able to recognize an instance of distributive property. So one giveaway with distributive property is there's always parentheses or grouping symbols. So that's a giveaway. But it's not just any time there's parentheses. It must be when there are parentheses and then there is a term next to the parentheses and it's being multiplied. That's distributive property. And so here's how it works. When you have a term outside, it gets multiplied by each term inside. So this A is going to get multiplied by the B and is going to get multiplied by the C. So A times B, we get AB. A times C, we get AC. And that's how distributive property works. It's the same thing if the term outside is on the right-hand side. We still multiply by both terms inside. A times B is BA or AB. It's the same thing. And A times C is CA or AC. That's the same thing. Does anyone have any questions so far on distributive property? Anyone have any questions on distributive property so far? Give me a thumbs up if you recall being introduced to this concept last year. Don't put your thumb up unless you mean it. Good, put your thumbs down. So that's the first major goal. Now, to actually understand what we're going to be talking about, we need some terminology. We need to understand some ideas and some words. So I've already used this word about 10 times in the first 5 minutes. The word term. A term is the part of an expression that's being added together. So I asked you to leave a couple of lines when writing this down because you're going to be writing in this. So write in that expression. Write the whole thing exactly as you see it. Negative 5x plus 20 minus 7x squared plus 34z plus 17x squared minus 12z to the third.
What?
So write that down. That is one expression. So, the terms are the parts of the expression that are being added together. So, I have a highlighter. You can use your pencil to circle. If you want to use your colored pen to draw circles or boxes, or if you have your own highlighter, whatever you need to do to understand. This is a term. Negative 5x is a term. 20 is a term. 34z is a term. 17x squared is a term. 7x squared is a term, but that's not really 7x squared. This is not 7x squared. Can someone tell us what this really is? We got a bunch of people who know. 1, 2, 3, 4, 5, 6, 7, 8, 9 confident people. Valerie?
7 times x squared.
That's true, but that's basically the same thing as what I said. 7x squared, it means 7 times x squared. But there's a part that I'm missing. Kadir?
Negative 7x squared.
This is a negative 7x squared. Because Ms. Cooper taught you keep, change last year, but you had the entire year last year to absorb it and use it. And so at this point, you should be able to automatically see that that gets attached to what comes after it. And so that means that's a negative 7x squared. This is not 12z to the third. This is negative 12z to the third. And so there are 1, 2, 3, 4, 5, 6 terms making up this expression. Does anyone have any questions so far? Good. So let's build on that. What is a coefficient? Well, I already gave you the definition here. It's pretty complicated sounding. But when you break it down, read the last phrase. The number is the coefficient of the variable. I'm going to use the exact same expression. If you do not want to rewrite it, you don't have to rewrite it. You can use your colored pen now, or your highlighter, or use a different shape. I'm going to use a different color. So the coefficients are the numbers in front of the variables. So this is a term, but this is the coefficient of the term. The coefficient is -5. Let's look at this term over here, 34z. The coefficient is the 34. It's the number in front of the variable. The 7x squared, which we already learned is not 7x, it's -7x squared. That's a term, just like I highlighted here. The coefficient is -7, the number in front of the variable. 17 is the coefficient, -12 is the coefficient of that term. This is a term, but it does not have a variable, and therefore it is not a coefficient. There can only be a coefficient if there is a variable with it. Does anyone have any questions on what a coefficient is? Because you're going to be using coefficients over and over and over again. Good. We're going to build on that now. Like terms. Here is a critical idea for today. What is meant by like terms? When you have an expression like this one, you have terms. There are 6 of them. I already did that with you here and here. But some of them are like terms and some of them are not. Like terms have the same variable raised to the same power. So now when you're trying to determine whether or not we have like terms, same variable, but it also has to have the same power. So let's look at the -5x. That's a term. Is there another term in the expression that is also an x? Someone raise their hand. It's a yes or no question, so it's not too hard. Is there another term in the expression that has an x? Dalton?
No, there isn't.
No, there isn't. This does not have an x. This has an x, but it's not an x to the first power. It's an x to the second. This does not have an x. That's an x to the second, and that's not an x at all. So there's no like term to go with the -5x, so that doesn't have any partners. Let's look at the 20. Are there any other terms that don't have a variable at all? Nope. So that doesn't have any partners. Let's look at the -7x squared. Is there another term in the expression that has the same exponent, the same variable raised to the same exponent? Michaela?
Yes.
What is it?
17x squared.
Very good. You said that perfectly. 17x squared and -7x squared are called like terms. Like terms. Now the 34z. It's a z, and this is a z, but this is a z to the third power. This is a z to the first power. These are not like terms. Why do we need to know like terms? Because the like terms get simplified. We need to know how to do that. We're going to get to that in a few minutes. Okay? Comments, questions on any of this? We're going to be using all of these ideas all throughout today. Good. We seem to be doing well so far. Last couple of terms that you're going to be hearing about. Constant terms are terms with no variables. Again, you don't have to rewrite this. Are there any constant terms in this expression?
Yes.
Yeah, there are. What are the constant terms in this expression? 20. That's it. Just the 20. Everything else has a variable, so that's the only constant term. And then finally, the overall goal for the day. The overall goal for today is to be able to simplify an expression. Simplifying an expression means that there will be no grouping symbols and all the like terms have been combined. And that's our goal, to be able to do that. Now, we're going to jump in and start working with distributive property. There's going to be some things that you're going to get lost on. I guarantee it. There's going to be some things you don't quite get right away. It's going to take some time. Because there's some foundation skills that I am assuming you already know. If you don't already know them, you're going to struggle a little bit. All right? So we're going to jump right in. If you're missing any terminology, just leave a line of space and you'll fill it in afterwards. So here we go. Example 1, distributive property. We're going to start with some simple cases and then we're going to work our way to more complex cases. Quite honestly, the simple cases after today, you're not going to have any of them. So I want you to look at part A. Don't do anything yet. But now I'm going to show you the last question that we're going to do together. So watch. "30 minutes from now, you will know how to do part A here." Right now, it should look pretty crazy to you. But it's a building process. To be able to do this, you have to be able to do this. And that's why we're starting here. Does anyone have any questions about that? Good, so let's do distributive property. Distributive property, first you have to recognize it. There are parentheses, there are terms inside the parentheses, and then there's a number or a letter right next to the parentheses. That's distributive property. So, we draw an arrow and another arrow. Each arrow means multiply. 8 times x, 8 times x. 8 times 9, 8 times 9. And we're adding them together, so we add them together. Now simplify. 8 times x is just 8x. 8 times 9, everyone can do mentally. Chris?
72.
72. So this, simplified, is 8x plus 72. Does anyone have any questions on how we did that? Good. Now it gets complex from here on out. Part B. Looks almost the same with different numbers. But in this case, we have negative numbers to deal with, and we cannot mess this up. So we have parentheses. We have two things being added, and we have a term next to the parentheses. So, multiply, multiply. Before I continue, I want to point out one thing that you were supposed to have really digested and mastered last year. Ms. Cooper taught you keep, change, change, and I've talked a little bit about it. But I want to show you what my brain does and what your brain should either already be doing or should start doing. So make sure you're looking up here. If you're not looking up here, then you're not going to understand. See this subtraction sign? This is what my brain does automatically. That's what my brain does automatically. Quite honestly, your brain should do it automatically also. If it doesn't already, it should start. Because this does not mean x minus 6. It really means x plus negative 6. I know in my head that that's a negative 6. You should also. So from here on out, you got to get used to subtraction really means plus a negative. So that means that we have negative 5 times x. Negative 5 times x. Plus negative 5 times negative 6. Now simplify. Negative 5 times x. Negative 5x. Negative 5 times negative 6. What do we get with that multiplication? Davis?
30.
30. Very good. Negative 5x plus 30 is simplified. Any questions about that? Okay? Now it gets more complex. So now things get more complex because now, instead of a number being on the outside, we have a variable. And here's where some of you, because you're not quite ready yet, might not understand. But there's some things that you were supposed to have learned last year. Hopefully you'll catch on soon enough. So we're going to multiply this times this times this. I already know that that's a negative 2x. So we've got negative x times y plus negative x times negative 2x. I multiply this outside times the first term, this outside times the second term. So let's see who knows what they're supposed to know. What do you get when you do negative x times y? What does that simplify to? Alexandra?
Negative xy.
That's it. Negative xy. So that one was actually easy. Here's the hard one. What do you get when you multiply negative x times negative 2x? Got 2 people who think they know. 5 people who think they know. 6 people. Michaela, you had your hand up first?
2x.
No, it's not 2x. I'll give you the 2. But you're missing a piece. Kalasia? It is 2x squared. Because this is an x, and that's an x. There's 2 of them. That's x squared. She was right, Michaela was right, that it is 2 because we have a negative times a negative, that's positive. And so, simplified, we get negative xy plus 2x squared. Negative 4x times 2x minus 3. Distribute, distribute. I already know that that's a negative 3 because my brain moved that subtraction symbol over for me. So a negative 4x times 2x, that's this first arrow. And then I've got negative 4x times negative 3. That's the second arrow. So let's see who's catching on from this other example. What does this become? That's the hard part. Sebastian?
Negative 8x squared.
Very good. Negative 4 times 2 is negative 8. X times x is x squared. Outstanding. What about negative 4x times negative 3? What do we get there? My quiet students, stay on your toes because I'm just going to call on you to see if you're even involved. Huh? I'm sorry? I just didn't hear you. $12x. Very good. Negative 4 times negative 3 is 12, and x being multiplied, so it's 12x. Excellent job. So, a lot going on here in this first example. Any questions on any of them?
And with the number of contests, looking at it, it's not easy.
Okay, good. I hope that continues for you. Any other questions or comments? Let's see how you do on your own. Checkpoint number 1, you got one question. You got 2 minutes. Oh, yes. Editing, what is it, editing? So they're not on the list. You can see if they're there, if they're not there, there's no way for you to edit. All right. Write it out. So started. You actually did the hard part. The easier part you made a mistake on. All right, so let's see how we did. What did we get? What did we get? We'll start with Stephanie, John, and then Chris. Stephanie, what'd you get?
3x cubed plus 6x.
All right.
I got the same for
Okay, say it one more time. Maybe I misheard. Go ahead.
3x cubed plus 6x.
Okay, what'd you get?
Negative 3x plus 6x.
Okay, so we have a slight disagreement. Sebastian in the back. Okay, the correct answer is 3x cubed plus 6x. So some of you are catching on to what you were supposed to have known last year and what you're learning now. So let me rewind for you. So you're multiplying this times this and this times this. So some of you are having trouble seeing what's happening. That's a negative 3. What is that? What's the coefficient of that number? What's the coefficient, Edgar?
-1.
Right. So in essence, the first thing you're doing is this. What's negative 3 times negative 1? Kadir? 3. So we don't need to write that down. Everyone should be able to do that mentally. So the second part is the x times the x squared. So let me write it this way and see if this helps. X times x squared, right? What's another way to write x times x times x? Caleb? X to the third power. So that's why it has to be x to the third. Here's where most of my students get confused. You're getting confused between adding and multiplying. And I'm going to be honest with you, some of you are going to struggle big time with this, and you're going to have to work through it. You have to know the difference between adding and multiplying. Different things are going on. So, again, here was the answer. It was 3x cubed plus 6x. Are there other questions? Okay, so let's build on this. Now, combining like terms. So far we did multiplying. Now we're talking about adding. And yep, you're going to have to keep it straight in your head. First thing, combining like terms. You have to first identify if they are alike. Well, I started out with an easy one. 10x and 13x. Are those like terms? It's a yes or no question. Raise your hand and tell me, is that a set of like terms? Caleb? Yes, they are. They have the same variable with the same exponent. So to combine them, you add the coefficient only. 10x plus 13x is going to be 23x. And that is it. Combining like terms means you add only the coefficient. You don't do anything with the variable. So here are the most common mistakes that I see. Students go, oh, I got it, Mr. Gowd. I got 10x plus 13x. That's 23x squared. Well, that's wrong. Because x times x equals x squared. X plus x equals 2x. So you have to know the difference between the two. We are adding x's. We are not multiplying now. So you have to know the difference. Here's another one. Students go 10x plus 13x. I got it, Mr. Gowett. That's 130x squared. 130x squared. 10 times 13 is 130. X times x is x squared. That would be great if this was a multiplication problem, but it's an addition problem. So you have to know the difference. So these are both the most common mistakes, and they are both wrong. I guarantee you, several students before the end of this class period make this exact same mistake at some point. It's going to happen. Your job is to learn from your mistakes. So let's continue to part B. Are there any like terms in part B that we can simplify?
Yes.
Like terms. Raise your hand, wait to be called on. Let's see. My quiet students, stay on your toes, because I'm going to call on you anyway. Shannon, are there any like terms that you see? What are they? Very good. She said that beautifully. 2xy and 8xy. They have the same variables with the same exponents. Combine them, you add the coefficients. 2 plus 8, 10xy. Are there any other like terms that we can combine in this example? Matthew, any other like terms? No? Okay, so then I'll just write minus 5 plus 3. Fung? Negative 5 and positive 3. Constants are always like terms. Can't you add negative 5 and 3 together?
Yeah.
So you add them together. What do we get when we add negative 5 plus 3? Negative 5 plus 3, what do we get? Valerie? Minus 2. That is simplified. Comments or questions? All right, let's continue. Are there any like terms that you see that we can combine? Any like terms? Extol? What do you see?
9xy and xy.
Very good, except he made a small mistake. He's looking in the right place, but he said something wrong. 9xy, and what should he have said after that? Kayla?
Negative x, y.
Negative xy. Could someone be even more specific? What does that really say? What does that really say? Dalton?
9xy minus xy.
Okay, that's true. That is actually very good. We'll get back to that in a second. Kadir?
1xy minus negative 1xy.
Yeah, that's a negative 1xy. And so now when I combine like terms, I have a 9 and a negative 1. What do I get when I combine those together? A 9 and a negative 1. Nathaniel?
8xy.
8xy. 8y doesn't have any partners. So it's just 8y. You're going to have another checkpoint in a second, but I want to show you here that one of your peers in another group did this on every homework question. This is what the student did. They said, yeah, I got it, Mr. Gallagher. 10xy and negative 2xy, so that's 8xy. And then they said, oh, yeah, 8xy plus 8y, so that's 16xy. They just kept combining things because they thought that that's what they were supposed to do. That's not what I'm telling you to do. What I'm telling you to do is you have to find the like terms, and those get combined. If they're not like terms, you cannot combine them. You cannot combine these. That's it. You stop there. Okay? Does anyone have any questions about that? Comments, concerns? Good. Here we go. Checkpoint number 2. 1 minute on the clock. Pencils down, colored pens up. Let's see how we did. So let's see how we did. I apologize. What did we get? What did we get? We got 1, 2, 3, 4, 5, 6, 7 confident people, so I'm going to call on all the unconfident people. We'll start with Daniela, Kalasia, and then we'll go to Danielle. What'd you get, Daniela? You didn't finish? You should be frantically trying to finish right now. Frantically. Kalasia, and then Danielle, and then I'm going to come back to Daniela.
Negative 10x to the power minus 4xy.
Okay.
Negative 12x squared. No, negative 12x cubed plus 2x squared minus 4xy.
Okay, so we got two different answers. Daniela, what'd you end up with? Okay, I'll come back to you on the next one. Michaela?
Negative 12x to the 6th power plus 2x squared minus 4xy.
Okay, so I proved myself right that some students in this class would make the mistake that I told you that someone would make. So when you combine like terms, you do not do anything with the exponents. So you get negative 12x to the third plus 2x squared minus 4xy. Don't worry, if you're still not getting it, that's what I expect to happen, but you're going to have to clear up your confusion over the next 30 minutes and this evening. Yes?
What negative 12x?
It is negative 12x
I
cubed.
put 12x cubed.
Well, that's unfortunate because you did the whole thing right, except you missed that this is a negative 5x to the third, and that's a negative 7x to the third. Negative 5 plus negative 7 is negative 12. Okay? And that's why we get that. Michaela, do you know where you went wrong? Okay. Any questions? All right, so now, as promised, we are going to put it all together. And so, to be successful with this, you have to follow basically the order of operations, but now I'm going to outline it for you so you know exactly what to do. The first thing you always do is you distribute. Distributive property is always done first. Then you do like terms. Distribute, then do like terms. So the first thing you do is your eyes should scan the entire expression to see if there is any distributive property. So I'm going to help you on the first one, and then we'll see who can pick it out in the second one. Here is the distributive property. Right there. Now this looks pretty confusing, but what if I did this? What if I made your life much easier and I did this? Oops, excuse me. What if I did this? Would that make things a little bit easier? Yeah, it would. So let's just operate as if this was the whole expression. This times this, that times that. Y times y squared. Dalton?
Y cubed.
Very good. Y to the third. Y times 1, well that's easy, that's y. If that was the whole expression, then we would be done and we would stop. But unfortunately, there are other elements to the expression. There is this, and there is this. So we didn't use those parts yet, so what we'll do is we'll bring them down to the next line. So it's really negative 3y plus this minus y to the third. So we took care of distributive property first, and that took care of this, and it became this. Now, find like terms. Who can find some like terms that we can simplify? 1, 2, 3, 4, 5 people can. Kayla in the back. Y cubed and? Those are all like terms? You said y cubed, and I'm asking, is there a like term to go with that? Negative y cubed is its partner. What do we get when we add y cubed and negative y cubed? What will we get, Extol?
Y.
Y? Where'd you get a y from? I know why you said y, but do you know why? Okay, well, we'll come back to you. Ziamara? 0. Anything plus its opposite cancels each other out. Y cubed and negative y cubed is nothing. So they just disappear. Are there any other like terms that we can simplify? Other like terms that we can simplify? Valerie? Very good. Negative 3y and y. What do we get when we add those two things together? Matthew?
Negative 3y squared.
No, you're multiplying instead of adding. We are adding now, not multiplying. So I understand that I called on you, but you got to try and start working this out. Kalasia? Very good. Negative 2y. We are adding negative 3 and a positive 1. That's negative 2y. And that is it. We are done. Now it's simplified. I'm not saying that's easy. It's not. But this is what you have to be able to do. Part B. Part B is here to illustrate one major idea. But first, you are to identify if there is a distributive property. Is there a distributive property in Part B? I see some people nodding their heads. John? Yeah, what is it?
2 to the power of C.
Dalton, do you agree?
Yes.
You do?
No, 2 times.
Well, that's what he said. He
No,
said
2 times C and 2 times negative B.
good. That's good. But I see some frantic hands. Sebastian?
Negative 2 times C.
Yeah.
Negative 2. That is the kind of thing, that detail right there separates the people in my class who have high levels of success and the people in my class who have moderate levels of success. So you have to pay attention to what's going on. So again, if I am creative, I can pretend for a moment that this is not here, and now I can really focus on what's going on. Now it's easy for me to do that and that. Negative 2 times C is negative 2C. Negative 2 times negative 8 is positive 16. But we did not use the 6C. So that comes down, and now I have to try and find like terms. Are there any like terms? Shannon?
6C and 2C.
You want to change what you said? 6C and...
Negative 2C.
Very good. You caught your own mistake. 6C and negative 2C are like terms. And when we combine those together, Matthew, I am going to put you on the spot again. What do you get? 6C and negative 2C. Very good. Yes, that's what we're doing. So what I'm saying is we're now adding them together. So remember, we're adding. Think about this. Adding. What's the difference between adding and multiplying? Okay? I know I put you on the spot, so don't worry about it. Stephanie? 4C plus 16. Very good. Now, I did have one more question, but I'm behind schedule, so I'm going to eliminate the third question. It is important because it's a real-world application of what we're doing, but I'd rather you practice on your own. So everyone, draw a line across your paper. On page 16, you're going to do numbers 22, 21, 20, 19, and 18. And then you're going to do 10, 9, 8, 7, 6. Colored pens up. Let's see how you did. Number 22. 13x minus 12. 21. Negative 2x plus 17. Number 20. 10x minus 7. That was a challenging one. Number 19. Negative 2x minus 11. Number 18. 14x minus 3. Number 10. You were asked to identify a bunch of things. The terms were negative 8, 2x, 5, and 11x. The like terms were 2x and 11x, and then negative 8 and 5, and the coefficients were 2 and 11. The constants were negative 8 and 5. Number 9. Negative 5x squared minus 2x. Number 8. 2x squared minus 2x. Number 7 is 4x squared minus x. And number 6 was 20x plus 15. Kadir?
For number 21, I put 17 minus 2x.
That's the same thing. 17 minus 2x is the same thing. Very good. Any other questions? I do apologize, I'm short on time. That's my fault, not yours. So if you have any questions and you're not sure what you're doing, you come to my care class any morning you need help. You of course go to your care teacher first, then you come to me. So everyone draw a line across your paper. Your homework is page 99, numbers 4 through 42 even, and then on 101, the ready to go on 1 through 12. Now, that is 32 questions, but there's a whole bunch of them that are really easy, but I put them in there and I included them because you need the practice. So it's not a punishment, it's not made to make you feel bad, it's just we need the practice. Okay? And you will have a quiz next week. That will be 3.1 to 3.3. Don't worry about it right now, but I'm giving you a heads up that there is a quiz.